So before we do analysis of circular motion, we must be clear between similarities and differences in linear and circular motion. Linear motion you must have understood by now. Okay. So what I do is I relate parameters of linear motion with circular motion so that new parameters of circular motion easily you can remember. Okay. Linear motion means straight line motion. Motion can be represented on a single number line. Okay. What are the parameters we use? Let's say this is the origin. From origin we locate the position of the body. So let's say this position is x. Okay. So first parameter is position, which we write as x. Okay. Second parameter is displacement, which is nothing but change in position. So initially body is over here, after some time let's say it moves. So position will change, so displacement is change in position. Similarly in circular motion, we can define position with respect to a reference line. So this is our reference line, and let's say initially particle is at point P. Okay. So this angle from the reference line is nothing but position. So here this position is called as angular position, which is theta. Okay. Similarly, if position changes, that will be called as angular displacement, which will be nothing but change in position. So initially particle is here, let's say it rotates, so angle will be increasing. So change in angle increased is nothing but angular displacement. Okay. Second term in linear motion we define as velocity. Velocity is nothing but rate of change in position. How fast or slow position is changing with time. Similarly here we can define angular velocity, which will be equal to rate of change in angular position, which we write as d theta by dt. How fast or slow angle is changing, that will be given by this angular velocity. Okay, so here this angular position units will be radians, so this unit will be radian per second. Next term comes is acceleration. So linear acceleration is nothing but rate of change of linear velocity. Similarly angular acceleration will be rate of change of angular velocity. Okay, so this angular velocity is also represented by omega. So this I can write it as d omega by dt, or this is nothing but d by dt, that is differentiation of d theta by dt, which is nothing but double differentiation of theta. Okay, right. Now similarly we can go on and on. Obviously time will be same for both the motions. Okay. If this acceleration is constant, we have defined equation of motions, which is nothing but v is equal to u plus at. This is vt relation. Next is displacement, which I write as delta x is equal to ut plus half at square. This is nothing but displacement time relation. Okay, and third equation is v square is equal to u square plus 2a displacement, which is delta x. So this is delta x, that is displacement v relation, displacement velocity relation. Similarly I can define the equations for circular motion if alpha is constant. So if alpha is constant, we can write it like this. First equation will be, now this is vt relation, so we will have omega t relation, which will be omega is equal to omega naught plus alpha t. Omega naught is initial angular velocity. Okay. Similarly second is displacement versus time, so here it will be angular displacement versus time. Okay, so angular displacement versus time, which I can write it as delta theta is equal to omega t plus half alpha t square. Okay, this will be omega naught initial angular velocity. So this is delta theta t relation, that is angular displacement time relation. Third, here we had displacement velocity relation, so we will have angular displacement velocity relation, which will be final angular velocity square is equal to omega naught square initial angular velocity square plus 2 alpha delta theta. So you can see that equations are also similar. So in a way all you have to remember is linear position, which is x, will be replaced by angular position, linear velocity will be replaced by angular velocity, linear acceleration will be replaced by angular acceleration. Okay, obviously time will remain time only. time will not change. Okay, so if these parameters you are comfortable, easily you can understand the circular motion as explained in the next videos. Thank you.